Okay, the live has started and can we start?
Yes, all right.
Okay. Just
Hey, this is Kumkum Patra, moderator for today's machine learning series, getting started with exploratory data analysis, which will be conducted by Mr. Abhinav Anand, a lead data scientist at Radius, a Reliance company with close to 7 years of work experience. He has been working mostly with startups for the past 6 years. He has helped those startups in building multiple products, mostly towards NLP and conversations AI. Going forward, looking to contribute more in this space as well as increase my open source contribution and give back to the community as much as possible. On the personal side, he really enjoyed reading books and novels. He's also a semi professional photographer with more focus on astrophotography. Now I will request Abhinav to take over the session. Thank you.
Thanks, Kumkum. Thanks for the introduction. And hello, everyone. This is Abhinav Anand, and today I will be taking your session on the very first episode of many episodes that will be coming up. And so in this one, basically we will be exploring mostly towards data and what is
Abhinav,
the
sorry, I'm interrupting you. Just before we move forward, all the people who want to ask Abhinav any questions, please do not unmute yourselves in the middle. Put your questions in the chat box. Everything will be taken at end by Kumkum, or you will be given a chance to speak at or ask your questions at end. Let him finish his session. We'll have half an hour for the Q&A round. I hope I am clear. Yes, Abhinav. Thank you.
Yeah, thanks, Jigyasa. So yeah, before so Kumkum, I think already gave my introduction, so nothing much to add there. And so in this session, what we will try is as much as so the more focus will be towards understanding how things are in this field. And so basically for anyone who's entering in this field, there are lots of confusions, and many of you who might be looking out for internships, looking out for any kind of job interviews, applying for job interviews, all or you may be already in a doing a job basically. So it will be helpful for everyone in understanding what actually you can expect from different fields of machine learning, artificial intelligence, and how you can better yourself using your different skills, which you can acquire throughout the workshops we will keep launching every now and then. So let me go ahead and share my screen. I think, guys, you will need to enable my screen sharing.
Host, can you please make Abhinav Anand the host?
All right. Yeah, I hope everyone can see their screens and it is visible.
Yes, sir.
All right. So for any data science project, the very important aspect of it is the data. And the data, so in any project, you spend at least 70 to 80% of your time dealing with data. So it is very important that we understand the importance of data and how we can handle that, what and exactly how to tell the story behind it, understand the problem statement, and correspondingly look in the data for the correct matrices and all of that basically. So data, before anything else, it's extremely important to get an understanding of, and the data can be of different types. It can be of image, it can be a text data, it can be a numerical data. So you can expect lots of different types of data as well. And so moving ahead, so I just want you guys to introduce a little bit about my workplace so that you are also aware of what kind of projects that are happening in a commercial environment, in companies wherever the tech is happening. It can be so currently I'm at Radisys, which is a Reliance company, and we are working closely with basically Geo. Geo is Reliance is basically, you can say, tech vertical of their entire company. And so we are doing a lot of things in there. And some of the projects I have tried to, I will tell you some of the projects that we are currently trying to do, though I will not be able to go into a lot of details because still, I cannot reveal everything because not everything is public knowledge at this moment. So though I will tell you what exactly field we are working in, what sorts of expectations you can have from those fields and all. So yeah, so one of the major projects currently which we are working at is conversational AI. And many of you might have already, not just might have, I think most surely you might have interacted with a different kind of conversational AI, be it Google Now or Siri or Alexa or a simple chatbot whenever you visit maybe a bank website or any other website. So you might have interacted with that quite a lot. So it is, so we are working in this field as well. And uh, next, so is sentiment analysis. Sentiment analysis, basically, it tells you or it allows you to know that what sort of sentiments or emotions are, you know, associated with any particular text which you are maybe sending to, or voice you might be that using to interact with the conversational AI or in just in a customer support. So the use cases of this is immense. It helps any particular, let's say, let's talk about, we can take an example like, let's say Zomato. You order lots of foods from there. They have a support system there. Sometimes you might have some complaint. You can go and you type usually. And so what they can do with those textual information is that they can analyze automatically without having to do, all those manual analyzing all those text sent by over millions of people's daily on a daily basis actually. So they can analyze that and they can see that what kind of sentiments or how happy their customers are in general with their orders. So like this, there are many use cases across for different organizations in a different way. So similarly, next we have knowledge graphs. Knowledge graphs. So this is kind of, you can think of like ontology. And so you don't have to worry about, you might not all have come across these terms and all of these, but later on you will get more familiar with it. But I just wanted to give you a taste of what in commercial environment we are working. So knowledge graph is one of the things which you build when you need to build some kind of a domain knowledge. So let's say you are working in a finance domain, or you are working in a or any other domain for that matter. So for that, let's say you want to build some sort of knowledge base or some sort of question answering you want to build. And then for answering such, let's say, a wide variety of questions, if you need to answer a wide variety of questions, how will you do that? So for that, you will need to build knowledge graphs. Already we have quite a bit of open source knowledge graphs, but they are limited in particular domain knowledge as well as commercial knowledge. So many companies build this for their products, for their services, so that they can answer questions of users in a automatic way and without having to intervene manually. So that is one of the use cases of knowledge graphs. Then we have question answering. Question answering done through ML. It's also called machine comprehension. So you will see the use case of this through different chatbots. If you will go to a bank website, they will ask you to enter your query, and they will try to find the answer from their facts or their knowledge bases, and they will try to answer from that. And they will. So what goes behind this is that whatever text you type, they try to closely match from the answers which they have, as well as pre-prepared questions they might have. So that way, this is one of the another use cases of question answering. Then there is language generation. I think many of you might have already seen about language generation through OpenAI's GPT, their big models. And so recently, there was a lot of news with GPT-3, launch of GPT-3, that it is going to, people were publishing articles just using language generation without even having to type anything. So this also has quite a lot of use cases. And as we go on, we will see more and more uses of language generation. So yeah, so this was just an overview of what you can expect from a commercial environment, different kinds of projects. So there are a lot more projects depending upon the industry and the type of industry. So yeah. And so this is in this first, basically we are going to today cover the episode 1, though I have in my mind a couple of future episodes which we will like to conduct. And though we would like to receive all of your feedback as well as to where your interest lies and what you would like to see from our side. So that we will have to see, and we will continue to bring more content to all of you. So in this very first episode, we are going to look at this machine learning field and what you can expect to find in here. And so basically, so this whole content, right? So normally what happens is you will already find a lot of content out there, and you might think that how it is going to be beneficial for you from already available content that are going to be out there. So what I want to emphasize from this series of episodes is that I give you as much as possible closely practical knowledge of actual scenarios which goes on while you are in a professional environment and you are working on a project for delivering results, actual results, communicating with your other business partners. So all of that, what exactly goes on, that insight I want to give you, because that is something which you will not find in any Coursera project or anywhere else. So that is my goal through all of this. We will also work on the skills, but this is one of the main aspects which I want to have in all of our skill building sessions. So also, so the very first thing you will do is you're going to go and find, look for internships and look for jobs. So for that, you are going to encounter interviews. You are going to find lots of job listings, internship listings on different websites. And there are going to be lots of different terms, job roles, and all of that is going to be a little bit confusing because of a couple of reasons. Because still our ecosystem or professional ecosystem is not that yet aware of all the things in the data science field or machine learning field. So many of the HRs across companies, what you will find is that they are using some job roles, interchangeably, and that might confuse you that what should be expected from you from a particular role. So I want to give a more clarity on that as well. And so that is the very first thing, because that is the very first thing you will encounter. So this is the very first thing I wanted to give some knowledge to you about. So let's talk about what are some standard roles and the associated skills which are going to be out there, which you will encounter when you will be applying for interviews and internships. So machine learning, research scientist, data scientist, big data engineer, or simply data engineer, data analysts. So these are kind of standard roles. So there are, you are going to find distorted or a bit of mixed roles as well, which usually companies also put out there. But these are the standard roles which normally you are going to find on any job listings. So let's talk about the first one, machine learning engineer. So in this one, so a machine learning engineer can belong to any field. So it can be either in NLP, natural language processing, deep learning, artificial intelligence, computer vision. So a machine learning engineer can work in each of these fields. And it is not necessary that you have all of these at one time. So some companies might expect you to have more than one, but usually it is more focused on just one, like NLP or deep learning or computer vision. So like this. So this specifically demands for you to have much more understanding of, or basically talking about this role as to what exactly you will be doing, that is building machine learning algorithms. That is the primary purpose of this particular job role. So uh, any project which you might come across, your main job will be to quickly implement any possible machine learning algorithms or probable machine learning algorithms, quickly implement and test and quickly give results. So that is the main role of a machine learning engineer. So for this, the expected expertise from the employers will be that you have a really good coding knowledge, and that coding knowledge is basically, so normally what happens is people think that data science is a different field, so I don't need to have a lot of coding skills and all those data structure algorithms. I don't need to know all of those things. But that is very, very wrong. So when you will interview with good companies like Google, Facebook, or any good company you will interview with, the very first screening round is going to be related to data structure algorithms. So it is really important that as you go on building your data science skills, you should also build your coding skills, your algorithm skills, how to apply them in what scenarios, how to write better codes. Those are really, really important aspects of the rules which you are going to apply in future. And the more number of experiences you are going to take in, the more the expectation is going to be when you will be switching your job from one company to another company. So let's say at this point, after 5 or 6 years, if you switch from, if you're switching your job, the expectation is going to be a lot. So you have to keep building this and not to let any aspects of your skills, be ignored. So that is a very important thing to remember. And before applying to any job roles, that might not be immediately written in the job listing, but they're definitely going to ask you in the very first round. So be prepared for that, and yeah, you will do good. So next is research scientist. I think that the name itself kind of implies what this role might have. So this is a very research intensive role. So you will be expected to have, normally, you are expected to have a lot of degrees in this, especially PhD, at least PhD actually. And if you do not have a PhD, you will need to have a lot of experience for getting this kind of a role. So normally what happens is every company had some R&D expenditure, and those R&D's role, this is basically an R&D role, and they basically develop solutions which basically are, or the companies basically try to then monetize them using their other other job roles which they have, or other employees which they have. So uh, so let's say a research scientist publishes something, or that comes out. So you might have seen Google employees are publishing new papers and something like that. So they are importantly, most of the time they will be research scientists. And what happens is, when they publish those kind of results, first they go out internally, and people like machine learning engineers and are so they are machine learning engineers are usually responsible for taking in the research from the research scientist and implementing them in actual products. So research scientists are, in a way you can think of like it's a bit separated from you can say from the business, directly from the business. It is not that much closely associated with the business that the company might be exactly doing, but it is more focused towards publishing any kind of a new solution or new algorithm for some different aspects of algorithm. So this is related to that. And yeah, next is data scientist. Data scientist usually, it's kind of a versatile role, if you think about it. So it's a versatile role. So you will have to have knowledge of handling data. You will have to have knowledge of a machine learning engineer as well, that is building and implementing machine learning algorithms. Then you will need to have a skill set of data visualization as well as storytelling. So this is kind of a versatile role. And usually most of the time, this is the abundant role that you will find in the industry at the moment, because it is easier to put everyone in this category, because people usually have, or basically end up doing a lot of different things at the same time, that is working with different kinds of data, implementing different kinds of algorithms depending upon what kind of data they are working with. So that is the usual idea behind the data scientist role. And next is big data engineer, or simply data engineer. This is a very specific role, and this specific role is mostly concentrated towards handling data. So it is really important. So what happens normally in industry is you're not dealing with data in sizes like couple of MBs or couple of GBs. What you are dealing with is thousands of GBs in petabytes and terabytes. So that's a huge amount of data to deal with. And even a slight lower efficiency can cause a lot of cost for the company. So they need to avoid that. And so they hire really good big data engineers, so that they can reduce a lot of infrastructure cost and automate a lot of data handling tasks as well. So that whenever a new client that may approach with a lot of data for you to work with, you have that kind of infrastructure to handle quickly and get on with developing models and actually delivering solutions. So which is usually an important aspect of any any data science project. You do not want yourself to be involved in things that is not going to be delivering solutions. So that is something. So in this one, you're going to, so the employers' expectations are going to be that you should have a knowledge of Hadoop, PySpark, or Spark, Apache Spark basically, or SQL, a lot of knowledge of SQL, other databases, MongoDBs, other DynamoDBs. So there are lots of different kinds of databases which are useful in different scenarios. So if you want to be a data engineer, you need to have a handle of that. Next is data analyst. Now, this particular role is more, I would say, outward facing, And what I mean by outward facing is that this role is more involved with other business partners of the projects and who will be directly dealing with clients. So you can, in this role, you need to have a lot of data visualization skills as well as storytelling. And along with that, to get that information across, you need to have a really, really good communication skill. Normally, you will need a good communication skill for any role, but this particular role has a bit of an extra expectation in this. So that is a data analyst role. And this particular role, mostly you will see in, you know, sales, marketing, or any kind of a CRM solution. So so what happens is the moment you receive a lot of data, or any organization, when they receive a lot of data from anything, from their, let's say, an advertising campaign, or from their sales numbers, the products which they have been selling, or you can take an example of Flipkart or any kind of a e-commerce platform. They usually generate a lot of data on a daily basis. So they need to have some kind of an insight, so they can recommend better products to users. They can recommend better services to users. So all of that comes from usually data analyst roles. So they need to have a really good understanding of the business in which they are working, and they will need to communicate and be in touch with their clients and their business partners to deliver that. So this is all about different roles and associated skills that you will need to build up for these. If you might have any questions, so please keep dropping them. If you have, or if you have already faced any problems regarding to any of these roles, we'll try to answer at the end of the presentation. Okay, let's move on. So this is something I wanted all of you to understand as well. So after knowing all of the jobs, let's say you get in a job, or let's say you are doing a project by yourself, a personal project that you might be doing. So normally you might ask the question that what are all the developments and what are all the necessary steps that are involved in any data science project lifecycle, end-to-end lifecycle, from getting the problem to delivering the solutions and deploying the solutions in production, and subsequently monitoring the performances in production. So there are lots of steps involved in that. And the previous roles which I showed to you basically correspond to which roles contribute where majorly. So it is more towards that. So you have to decide as to which aspect of a data science lifecycle, or what exactly you want to do afterwards in your professional career. So figuring that out would be really helpful for you, so that you can apply to relevant jobs. So sometimes what happens is people take up some particular roles, but later on they do not find that quite interesting and quite entertaining, and they immediately get bored, and they try to switch jobs, which you should avoid as much as possible. So it is really important that you understand the different roles and different expectations, and what exactly and where that exact role will be exactly contributing to in a data science project life cycle. So let me go through this. So the very first thing that's going to happen is you're going to, or any company is going to receive a lot of data. So data engineering will come in there. So you can see there, right? Feature store. This is nothing but data warehousing, or basically keeping a data in a particular order. So this is a job of a data engineering. Okay, so feature store and data engineering. So these two are the jobs of data engineering. So they are responsible for any incoming input data from clients or from company's own data. So they are responsible for handling that data at a scale, basically. So this is that. After that, the immediate next thing that happens is that the company, what the company wants is they do not want to immediately jump into ML modeling. And what they normally want is to have some sort of insight before they take up the job of ML modeling and doing and figuring out solutions to the problems. Even before that, they want to have some kinds of insights on the data. So that's where the data analysts come in. So they need to do data analysis. So usually this happens in a couple of steps. So the very first thing they're expected to achieve is that on the new data, they are basically expected to publish a preliminary report of the data. That what kind of insights they found immediately as they, in a couple of days, or it can be a week, what kind of insights they found from the data. According to that, so that other business partners are also aware of that, where the data stands, where the data is sufficient, or you need to ask for more data from your clients so that they can go back to the clients and ask for more data, so that otherwise what will happen is, if they will go ahead with ML modeling and all of that, and then if they will find that the data is less, then it will be a lot of hassle of asking for more data from the clients, because that will look really bad on the company itself. And it will be also, there will be also a lot of wastage of time. So data analysis is very, very important, and it plays that kind of a role whenever a new data comes in. And later on, data analysis keeps happening in. It's not like it stops after that. Data analysis is going to keep happening, because the kind of insights that you can draw from any data is really unlimited. So the more you will observe, the more you will analyze the data, the more you are going to bring out the value from that data. So usually they keep continuing and they keep improving the insights gradually on the same data, or the feedback they might receive from other teams, like modeling teams or research teams. So they're going to keep improving on that. So that happens in the next step. After that, DS experiments. So there are a lot of experiment that happens where basically the ML machine learning engineer comes in. So the role basically which I showcased here. So machine learning engineer. This is the role basically which works a bit more in this aspect of the data science lifecycle. What they do is, after taking in the data from the data engineers and the data analysts, what they do is they quickly implement machine learning algorithms on that. They test a lot of machine learning algorithms on that, not randomly, but depending upon the insights that has been shared by the data analyst, and what kind of, they basically decide first, because there are hundreds of models out there. So it's not like a machine learning engineer is going to have that luxury of implementing each and every possible algorithm and then going in, basically. So that usually doesn't happen. So what they do is they take the insights that is being provided by the data analysts, or the insights they are able to curate from whatever information they receive. So they implement machine learning algorithms on the data, and they publish results, that these kind of results they have achieved on that. So that is there. And after that, what happens is, along this, you can say that ML model engineering basically happens. Model selections and a bit of a research can also happen in this stage, ML model engineering. So here, research scientists and all of them, basically they will be involved in finding out solutions, better solutions. If ML engineers are having tough time achieving good results, if they were able to achieve good results from the data which they had and the algorithms which they already knew about, then they will go ahead with that as a solution. But if not, other research scientists and other basically they can pitch in and they can publish more results, and they can take up the tasks of that basically. So that is where research scientist roles and all of that comes in. And after that, so after all of this development, what comes next is you need to be able to, uh, put some or basically have a pipeline and have an infrastructure for deployment, how and performance monitoring. So all of that is included in the MLOps basically. So this is not kind of a directly data science role, but it is more of a evolved DevOps role, which has come into ML as well, because all of this maintenance, model registry, source repository, performance monitoring, deployments, CI/CD pipelines. So all of that they need to implement so that whatever the model that has been developed, that can be taken to production as soon as possible, and with as efficient manner as possible. So, and that too, they have to do it at a scale. So like a single model can be serving millions of people. So how do they do that? So all of that they have to take care of. So MLOps is responsible for a lot of that. So so basically, this is a complete overview of the data science lifecycle which you are going to encounter. And and in this one, basically you have to figure out, right? Again, I want to emphasize that the different roles is going to have a different responsibility, but also since most of you will be starting out and have zero experience, so you should explore as much as possible. So initially you should explore all the aspects of a data science project lifecycle, and you should see that at least for a couple of years you should keep doing that, and then you should see that what actually interests you. You are whether you are more interested in data engineering, or you are more interested in doing research based projects, or you are more interested in machine learning engineer kind of a role, so or a data analysis kind of a role. So that you will have to gradually figure out. You can't figure out immediately. So the very first thing is to explore as much as possible, do all of the things by yourselves, do different projects, and as much as, so there is Kaggle is out there. You can go on there and you can do the projects to get maximum exposure to different kinds of projects, and different kinds of data, and what are all the steps that are involved in the data. You basically doing all of that by yourselves will give you a lot of insight into it, and also will tell you, or you will get to know that which aspect of it is that you are most interested in. So again, so in the beginning, what I was talking about, so why I am emphasizing on the data so much. So many of you, I think, might have already heard of the name Andrew Ng. So he's a he has been working in this field for quite a lot of time. He led Baidu, he led quite a lot of research at Google, and now he is doing a lot of work on his own company and it is a startup. So this is a term basically coined by him, basically data-centric AI. And I have to say that I completely 100% agree with him on this. Not because he just said it, but because from the past experience and the past couple of years that I have been doing. So what I have seen is that data always plays the important role in any of the project which you are going to do. So you need to have a really good understanding of the data. So only then you will be able to deliver a really good result. So as I said, there are usually 70 to 80% of the efforts are involved in handling with data, taking out insights from the data, and any kind of noises or any kind of duplicacies, or so lots of situations that can happen with data. You have to deal with that first before you can even think of doing machine learning on that. So it is very important that you as well emphasize data more without or directly jumping into machine learning algorithm first. So understand the data which you're working with it, and get as much insight as possible. And if you are able to get that insight is going to help you choose the best possible model for that data, and that will help you achieve the best result for that data, and which is basically important in any commercial environment, right? So it's not like anything else is important for a business. They just want to make money, and for that you need to deliver solution, and that solution can be at many times very critical in nature. Like let's say some of you at later point in time, if you try to go in healthcare industry, where it is going to be really critical of the solution which you deliver. So you will need to be very, very careful of what you choose, how you derive insights from that. So all of that is going to be really, really important from the different projects perspective. So that is there. So what I'm going to do now is I'm going to show you some practical demo of data visualization, which is the goal of today. So basically exploratory data analysis. So how you can do data visualization on what sort of graphs and visualization you can build. So all of that I will try to show. So hold on a second. Uh, Give me a moment, please. In the meantime, if anyone of you have questions, keep sending it out. One second. So normally you can do any kind of experiment. So usually you have platforms available like Google Colab, free of cost, and Jupyter Notebooks you can also run for quickly experimenting with it. So any of the tools you can use. So I am going to share my notebook. So I will provide this notebook at the end of the session so that you can also play around with it. So my notebook is visible to everyone, right?
Yes.
Okay, perfect. Hold on a second. Let me see if I can make it bigger. It's the size is not a problem, right? Everyone is able to see properly.
It's readable. Yeah.
Okay, perfect. Let me see if I can make it full screen. Apparently not. Okay, so don't worry about this. These are imports. Sometimes people get a little bit overwhelmed with seeing a lot of imports in, but this is completely normal. And depending upon what different libraries and tools which you use, So depending upon that, it is going to be there. So basically in this, what we are trying to do is we are going to explore one of the projects. So this is, I took a very simple project. So many of you, if you would have already explored Kaggle, might have come across. This is called a house price. So later on, you can go on there as well to explore more on this. And so I took this as a simple example so that I can show you how you can go on about it, about handling the data, how you will do a visualization, how you can plot graphs, all of that. And at the same time, basically, so many of you might not have that much exposure to machine learning algorithms and all of that. So what I want to emphasize from this is that whatever you have already learned from your maths and statistics, right? So you can actually apply them in here. Okay, so it is really important that whatever we are learning, we are able to apply as we go on. That will give a meaning to what you are learning. So I hope I will be able to cover as much as possible from what you have already learned through foundational courses. So I will try to showcase that to you. So quickly, what I want to do is just show you the data. Um, you're able to see the data, right?
Yes.
Okay, perfect. So there are lots of columns in this data. So don't worry about seeing so many columns. That's completely fine. Actually, it gives you an opportunity to explore more types of data and more analyze more number of data points and different columns. You can apply different metrics which you have learned, which can be variance, covariance, relations, correlations. So all of that, right? Mean, median, mode, all of that. So all of these individual concepts which you learned from your stats and maths, I want you to apply all of that through this data and see what kind of insight you can see from it. That will help you to get a better idea of what exactly those metrics and those stat terms exactly tells you about, and you will be able to later on apply it in a much better way. So normally you would have seen the data as nominal data, ordinal data. So different kinds of data you had studied in your statistics. Normally, if we translate that in simpler terms, it becomes like numerical data and categorical data. So today we will talk about numerical data and categorical data, and we will try to analyze them. So we have a lot of columns in here. Some are numerical, some are categorical. Okay, and so a lot of column will have missing values. A lot of column will have wrong informations, or which you can call as noise, basically. So we will also see how we are going to cover that, or how we are going to handle that in an actual project. So let's go ahead and do that.
Abhinav, we got a doubt here in the chat box. Is this open source?
Yes, this is, so whatever I'm mentioning, it is completely open source, and I will provide you all of this, so you don't have to worry. I will provide you each and every single information which I am putting it in here, so that you can play around with it at a later point in time. So yeah, it is completely open source. If it would not have been open source, I wouldn't have been able to show you as well. So there is that. So yeah, okay. Coming back to our coding.
So one more question is there. How should I make use of Kaggle as a total beginner in this field by Paramveer Singh?
Sorry, by?
Paramveer Singh.
Okay, Paramveer. Okay, so Paramveer, there is nothing much to it. If you have used if you have used an editor before, or any kind of a Python console, or any kind of a Python Jupyter notebooks, or Google Colab for that matter, so you can. So I can actually let me do one thing. Let me show you how you can actually do that. So that would be a good demo for everyone, how they can utilize the Kaggle platform. So it wouldn't take much time. So I think I should do that. So, okay. So what I'm going to do is I will open a Kaggle project. I will actually open this project itself, and I will show you how you can start doing it. So when you will log into Kaggle, this is the page you are going to see. I hope everyone is able to see. Can anyone confirm?
It's visible, yeah.
Okay, perfect. So I'm at home, Kaggle page. So from here, you can go to competitions. Click on that, and you will find a lot of competitions which are currently active, and a lot of competitions which has ended. So you can try any of the competitions which you want, but the first recommendation is that you can go ahead and simply search house prices. In the search bar, you will get the house prices. You can click on the project. Okay. You, after coming in here, you can read all the descriptions. What is the data about? What is this project about? How is the evaluation, and what kind of metrics they're considering for evaluation? So normally for any projects, normally you will have accuracy or F1 scores or losses. So depending upon that, you will have to use the correct metric for the evaluation. Though you do not have to worry about the evaluation in the beginning. If you want to just try out, okay, so don't worry about any of these things. What you need to do is just go to the data. Okay, you can either download this data to your local machine, and you can start playing around on your local machine itself. Otherwise, there is another option for you to code. So you can go and click on code, and here you can create new notebooks for yourself. Okay, so by clicking on new notebook, it will take you to, it will create a new notebook for you, and it will run completely in cloud. Okay, and you can also access your data on the right side, so you can load it up, the data in your notebook as well. And just as you do it on your local machine in your Python editor, whichever you are using, it can be a PyCharm, it can be VS Code editor, anything you can use, or you can use this online notebook as well. And you can go ahead and you can run the code simply. So yeah, that it is as simple as that. So nothing complicated about this. I hope it is clear. If you have any other doubts, do drop in messages, and don't worry about this. So what we will do is, after this session, what we will try to do is we will try to create a group where you can ask all of your questions, and I can try answering as much as possible even after the session. During the session, I will try to answer as much as possible, and even after the session, you can put in your questions there. So do not worry about that. We'll be there with you. All right, let's get back to our coding. All right. So the very first step you're going to have is loading the data. And as you can see, the data set you are going to have on the right side of it. You can even add more data. If you want to add any other data, you can simply go here and click on add data, and you can upload data directly in here. And you can then come in here and you can read these data as well. So for reading data, right? So the very first, it's a very popular library. It's called Pandas. Okay. So through Pandas, you can read CSV data, you can read textual data, you can read Excel data. So you can read all different kinds of data, and the data structure which it creates, Pandas, it's called data frame. So currently I'm reading this data through Pandas, and it is creating, so basically train and test data are available here for this project. And so it is being read. So what I'm going to do is first, I will run this. So I'm running the import. So there are lots of libraries in here. So as I go on through this, I will gradually tell you that which library is needed where. So don't worry about this import at this moment. Then I'm going to read the data through Pandas, and it's going to load the train and the test data in two separate data frames, that is train and test data. And so the very first thing basically that is happening here is that we are concatenating the train and the test data to do a little bit of operation on the data. Okay, so normally depending upon what kind of a test data you have, you might not, or you might want to do some kind of a processing, or you might not want to do some kind of a processing. But here we will need to do a little bit of, we'll do a little bit of analysis on both the train data and the test data. So we are combining that in here. And so if you have any doubts on any kind of a syntax or what is happening, or you are not understanding about it, don't focus on the code that much at this point. Okay, so subsequently we will cover more in depth, especially on coding and how covering in each line what exactly is happening. So for this today, do not worry about the coding part, or you are not able to understand some particular syntax. Just follow me and what I'm trying to showcase you. So you will get the understanding of what to expect from it, and later on you can play around with it, and you can, if you have any doubts, you can ask questions. So what I was talking about, right? So we have in this two types of data: numerical data and categorical data. So so what we want to do is, we cannot analyze numerical data and categorical data together. So what do we want to do is, we want to separate the numerical data from the categorical data. Okay. So these two lines basically achieves that. So this one basically gets you all of the categorical datas, and then later on you can see. So wherever you see object, right? So wherever, I can tell you this much, that wherever you see object, so you can consider that as a categorical variable. And wherever you see numerical and those kind of a thing, that is a numerical variable. So there can be different types of numerical variables, and one can be a continuous numerical variable, and another one can be a discrete numerical variable. So it depends on us how we treat the discrete numerical variable. We can either treat the discrete numerical variable just as a categorical variable, or we can transform it in some other way for treating it as a numerical variable. Okay, so I hope everyone already understands. So again, so whatever the terms I am using here, it should be familiar to you from the stats which you have already learned from your foundational courses. So if you have any confusion in any of the terms I'm using, let me know. But I will make sure that these are the terms which you are already familiar with. So there shouldn't be any problem there. Okay, all right. So our job initially is to segregate the numerical and the categorical variable. And next, what we want to do is we want to, do some kind of analysis on the categorical and numerical features, basically. So pandas here again, I am using pandas and matplotlib basically to do any kind of handling data, and matplotlib for visualizing data. So matplotlib is a library which you can use for graph plotting and visualization, basically, for your data. So matplotlib is a library. There are parallel libraries like matplotlib, like matplotlib is there, seaborn is there, plotly is there. So there are similar libraries out there. You can choose whichever you like. So there is no as such restriction that you should use this particular library or that particular library. You can choose any visualization library which you are more comfortable with, and you can go ahead with that. In this tutorial, we will be using matplotlib library. So yeah. So having said that, I will run these codes as well. Quickly, I'm going to run this. So you're not going to, at all the places, you're not going to see the outputs. Mostly, I will try to show you the visualizations when happen. So you can see in this here. So you can, so what happens normally is that, like in this case, you will be dealing with a lot of columns of data sets. And it will not be feasible for you to individually go and check which is numerical, which is discrete, which is continuous, which is categorical. So all of that you will have to do in an automated fashion for that many larger number of columns. So using pandas, you can do all of that processing. You can select numerical columns, you can select categorical columns in one line of code. So now this is the first, after running this particular cell, you will see the first graph plotting that will happen. And this graph plot is going to be a box plot. I think you already got an introduction to box plot in your stat courses. So I hope you will be able to make sense of the box plot a little bit, but I will explain a little bit about the box plot just so that if anyone needs a recap. So as you can see here, we have lots of graphs in here. Okay, I think what I'm gonna do is maybe turn the night mode on. Okay, it's fine. It's fine. So what you are seeing here is basically box plot of numerical columns. Okay, you don't have to worry about at this point which numerical column is doing what. So what normally a box plot does is that you see the two ends, right? The lower end and the upper end. These are called whiskers. And the lowest whisker tells you the minimum, or for that particular data point, the minimum value for that column of attribute. Okay, and the highest values denoted by on the top whisker. Okay, so these lines are called whiskers. Remember that. These lines, thin lines, which has been drawn, are called whiskers. And these points, the line which meets with the box in here, this is called the quartile 1. I think you are also familiar, you should be also familiar with quartile term. What quartile means is 25% of the data. Quartile 1 means lower 25%. Quartile 2 refers to the next 25%. Quartile 3 is the another next 25%, and quartile 4 is the last 25% of the data. That is the quartile. And so this the first point which is meeting here is the quartile 1. The line in between the boxes which you see, it's called the median. This represents the median of that particular column. Again, the top whisker which is meeting with the box, this is called the quartile 3. And the top value is the maximum value of it. So this is your a typical box plot. And so what this box plot basically tells you is the distribution of the data. So the box you can see here, right? Even though my whiskers are from here to here, but the box is more concentrated towards here. What that means is, even though the minimum and the maximum values are this far apart, most of the data basically lies between these values. So there are through this plot, basically you can get the idea of your distribution of your data. So this is a box plot. I hope box plot is clear with everyone. So you will find, so each of the graphs which you are seeing is for a different numerical column, and that is why you can see that you can see different types of box plot, basically with different concentrations and different positions of the boxes inside the plot. So this is a typical box plot which you will encounter, and this helps you in analyzing the data, in understanding the data, whether what is the distribution of it is, and it directly gives you what is the median value of the data. All of that points, it directly shows you through the graph itself. So you don't have to go and calculate it separately. So this is your typical box plot. Next, we are going to do another plot. So this is a simple bar graph, basically. Okay, so these bar graphs are for numerical columns again. So for these all, so I will let you play around with this. So for now, just see that first, we went ahead with the box plot. It tells, or basically it lets us visualize the data in a much more sensical way and in a qualitative way. If I have to be precise, in a qualitative way, you can observe the data quickly. Bar graphs can also help you with identifying or quantitatively measuring the data. But what it misses from the box plot is that you are not going to see what are the, or where the more concentrated data is, what are the ranges, and what is the median of the data is. Those informations are not going to be in a bar chart. So depending upon your particular use cases, you can plot either box plot or bar chart. Okay, that is there. Moving on. There are a couple of more. So uh, my more emphasis was to give you as much different types of plots as I can, even in the same box plot and the bar graphs, so that you can see how different data points are represented in here. You can later on, you can come and see and play around with it. So I'm gonna move quickly with this and introduce first two different kinds of plots that we're going to see. So another common metric which you are going to come across while doing data analysis or data exploration is the correlation. So correlation is one of the factors which you're going to need if you want to identify that. So for this particular data set, for us, sales price was an important factor. Okay, so this whole project about house prices, sale price is the important factor which we are trying to predict from this whole project. So we want to see that for a target value, that is the sale price, what kind of a relationship other columns or other attributes have with our target variable. So when you get that information, it is really helpful in identifying that which are more correlated features corresponding to my target variable and which are very least correlated features. So the usefulness of it is that. So normally, as you saw, we had 80 columns. 80 columns is still quite less what you will encounter actually in a commercial or in a professional environment. Normally, you will encounter thousands of columns in a particular data set. Then what will happen is normally you do not want to take all those 1,000 columns and go ahead with it. What will happen is a lot of those columns are going to be nonsensical. So you want to see whether those data points or among all of those 1,000 data points, what are correlated or what are not correlated, so that the uncorrelated data points you can simply drop. Okay, you can simply drop and have the minimum effect on your model's accuracy. Okay, so that is something correlation becomes helpful in. Okay, so this showcases how sales price is correlated with different attributes in the project in this data set. So you can see sales price is 80% correlated with overall quality, right? So this is living area. So all of the different attributes which are present for houses, right? This whole data is about houses. So like the different attributes which you have is like overall quality, what is the living area, what is the garage, or what is the garage area, what is the, so different like this, years built, in which year it was built. So you have different data points corresponding to a house which you can think of, right? And this shows you what kind of a correlation sales price have with each of these different attributes of this data. So all of the data which you have, you can see, you can even have, we have negative correlations, we have very low correlations. So we can basically ignore very low correlation data sets so that we have less overheads when we are going to train, because the more data you are going to consider and the more nonsensical data which you will try to introduce, the more noise it is going to introduce in your project, and the harder it is going for you to fit that data on a model. So normally what your primary goal is to generalize the data set or generalize the model on the data set, basically. So if you are able to do that, that is really good. But if you are not, you need to go back and look at the data, whether if my data has a decent amount of data or what kind of a quality of data I have, if I need to drop something, if I need to add something. So all of that analysis you can do through different metrics points. One is visualization, like we did before. Then we have correlation. Others we will see more. Now we are going to plot a scatter plot. This is another type of a plot. So what? So you have to be careful, right? Which data points you choose for plotting. So for a continuous data type, you will want to have a different kind of a plot. For a discrete kind of a data point, you will want to have a different kind of a plot. So scatter is one of the plots where you will want to have a discrete data point for plotting. Okay. So again, there are, you can see different.
I have a doubt.
Yeah, you can. Yeah, you please go ahead and put it in the chat. We'll try to pick it up.
Okay, right. Sorry.
Yeah. Thanks. So anyone, if you have a question, please put it in the chat. Moderators will pick it up. Okay. So don't worry about that. Okay. So we can see a lot of different scatter plots for different attributes and values. Okay. You can later on explore each of the scatter plots, what exactly each of that means. I'm going to go ahead and show another kind of a plot. So this is a correlation heat map. Normally it's called it's plotted using the correlation itself. So this basically gives you the correlation between parallel at different attributes. And this graph tells you where most of the correlated data is lying. So this is for that purpose. This is nothing but visualizing correlation, just to be again clear. So this is a correlation graph, you can simply say. Okay, so all of this was related to visualization. What I'm going to do is I'm going to first take questions before I show a little bit of data pre-processing, because I don't want to go a little bit more in depth later on in other sessions. The primary goal with this session was to show you what all you can explore with the data and what different actions you can take with the data. So I think, yeah, moderators, if you can help me.
Shruti has a
with the
doubt.
question. Yeah.
Does correlation also account for inverse relationship with the target?
Yes. So you can see, right? What happens is whenever you get negative correlation, that means that you have an inverse relationship. So if you have a positive relationship, that means you have a direct relationship. If you have a negative relationship or negative correlation, that means you have an inverse relationship. It's as simple as that. Any confusion in that?
Shruti, is it clear?
So what we can do is, if you guys have any doubts, you guys can raise your hands and we'll let you unmute. So I think that would be a good option.
Yeah, so following up on the same question, so when you decide to call a few variables noise, it actually means that positive or negative, they just have a small absolute value, is it?
You are talking about correlation, right?
Yeah. How will you choose which variables to not take forward?
Yes. So all the values will be between -1 to 1. Okay.
Mm-hmm.
So if you have higher values, that is closer to 1 and closer to -1, what you can usually do is you can either take them or just simply ignore the values which are really small, right? So you can see the value like 0.0001, 0.04. So these are really small values. So these columns you can easily just skip. Okay. Yeah. Is that clear?
Yeah.
Yes, Vikram. You can
Yes.
go.
Hi, Abhinav. The correlation matrix that we are seeing on the screen right now. So I thought that this is like between the input versus the input. So if you have 10, 20 input variables, and so we basically plot this against each other to see what input variables can be dropped. But in this snapshot that you showed above, it is between the input variables and the sale price. So are we just trying to understand how much each input variable contributes to the output?
So
I
you're
don't know.
talking about, are you talking about this heat map,
No,
or
no,
are you
not
talking?
about this. That single line matrix that you had
Okay,
above the,
this,
yeah,
okay,
this one
this
right
one.
here. Yes, 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 yes.
Yeah. So this is only for the sales price. This is not for that. The other heat map which you're saying, that basically which you're talking about, is that.
Okay.
Okay.
So what does that single line matrix convey? The
So
contribution of each input variable to the output, is it?
yeah, you can think of it like, so let's say you are modeling and this is your target variable, and you have a lot of columns. So now you want to see that how each of the columns or how each of the data points is contributing towards the sales price, so that accordingly either you can drop it, you can take it, or you can transform the data. I'm not going too much deep into it, but there are more actions you can take depending upon this. So yeah, this is just for showcasing that how for this target variable, that is sales price, how other variables are related to the sales price.
So one more question that I have is
Yeah.
that if say two variables are correlated among themselves from the heat map, then also you'll be removing one of those, right?
So the action is going to be a bit different. So
Mhm.
let's say two variables are correlated in nature. Okay.
Mhm.
So what we will do is we'll not remove it, but rather we will transform the two variable or maybe combine. So let me give you an example. Okay. So let's say for on a single person, or in some cases you are collecting in one column you have weight, in one column you have height. Okay.
Right.
Weight and height. And so weight and height are usually correlated, quite a bit of correlated variables. Okay.
Yeah.
So what you can do is you can remove both of them and you can introduce another term that is called BMI. So that is called transformation. So depending upon the types of data and depending upon what kind of projects you are working, you are going to find lots of such opportunities through plotting correlation. So what
Uh,
that will help you is that reduce, let's say you have a lot of columns, that will help you not just remove redundant information, as well as reduce the data and quicker the training process. So yeah.
so I also wanted to confirm this. Do all the machine learning models that we run have an underlying assumption that all the variables are independent?
That depends on the machine learning algorithm you are using. If you are talking about linear regression, that's one of the assumptions.
Okay, and how do we find out which ones have that assumptions and which ones don't? Okay.
That is very simple. You can just go ahead and Google the assumptions. That you will be able to find. But if you have confusion, let me know. I'll be able to help.
Okay, right. And if our model does have that assumption, what all measures would you take to ensure that the variables are independent?
Yes. So let's say if I were to implement a linear regression for this particular project, what I will make sure is that I remove all the correlated features, or at least transform them in some way so that there is no more correlated features. The example which I gave of weight and height, right? So I will not keep two features which are correlated, so that linear regression doesn't either overfit or doesn't give misrepresented results.
So is there a tolerance limit for the correlation number? above which you won't handle or something like that?
No, it totally depends on the project. So you have to be practical about the project. You have to look from the perspective of the project. What usually at times what gonna happen is that even though some for some variables, if the correlation is really low, that might be an important variable for your project. Okay, so in that case, you might not be able to ignore it. You will need to circumvent it in any other way. Okay, you will have to, let's say there are you will have to do some kind of a log transform or some kind of normalization. So there are other actions. So I'm trying not to go too in depth in this one, because all of this will cover in successive sessions. So there are lots of actions which you can take successive that, as I said. So one of the couple of actions is log transform, normalization. So you can take that first and then again apply maybe correlation or something like that and see how that improves for your project. So yeah.
Thank you so much.
I have a question here.
Yeah, please go ahead.
So while checking the correlation of the data set, are we dropping the data set using PC, or we are just dropping with using pandas? I mean, as we know, which here the data set are very small. So we just dropping the data set using pandas, or we are using PCA?
So you can, again, so that totally depends on the situation. So if, let's say, if some particular column has lots of none values, okay, what I will do is I will simply go and drop it using pandas. I will just do pd.drop, that's it, df.drop basically, or something. Okay, so I will just drop it. And where you will use PCA is when you have, so after dropping all of these, after dropping through pandas and doing all of this, and let's say you still have 1,000 columns, okay, and still that is a lot for you to build a machine learning model on, or to get insights on, or to publish results on, right? In that case, what you will do is you will then apply PCA on top of it. And after applying PCA on top of it, you can reduce the number of columns quite drastically. So yeah, that totally depends on the project and the situation. Does that answer your question? Hello? Hey, you guys can hear me, right?
Yes, Abhinav. It was Deepak, right? Yeah, it answers this question. So, right.
Okay.
Thank you, John.
All right, great.
Anyone else, please do raise your hands if you have questions. We will be wrapping this session in next 10 to 15 minutes. Is it all right, Abhinav? Or
Yeah, that's completely all right. If you have questions,
yeah.
we can go ahead. Yeah.
Yeah. If any more questions, please do raise your hands, and also do fill the form because it will help us schedule the next sessions. Plus take it forward from. Thank you.
So as I said, so this session was a very introductory. We are planning in-depth session. So as you said, I skipped a lot of details in between. So those were introductory details. So we'll be doing in-depth sessions afterwards as well. So let us know about your interests, what you will want to see, in what way you will want to see those informations, how interactive you will want to have it. So all of that will be really helpful. So please do provide those feedbacks.
Okay,
yeah,
so we have Vikram.
Vikram,
Yeah, could you go with the question?
Yeah. Hi, Abhinav. I know this is just an introductory session, but like one question I had was like, so we use these scatter plots, and a lot of ML algorithms require the data to be in a certain distribution, like, normal distribution or something. Please correct me if I'm wrong here. But then when a lot of data sets don't meet that requirement, do we then remodel the data to fit a particular distribution?
Yes, so those comes, so why I didn't introduce those concepts is because that comes after you have analyzed your data, or at least you have got a slight insight on your data, right? Only after plotting the data points, you will get to know whether your data is up to a particular hypothesis testing. So what you are basically talking is that we can do a lot of hypothesis testing, which we, we would have covered in stats. And we can see whether particular data is Gaussian distributed, normal distributed, or any other distribution, binomial distribution, what kind of distribution it is, right? And if that is not distributed, so then we can take appropriate actions. We can take appropriate transformations to convert the data into that particular distributions. But even before that, it is necessary that we observe the data, just observe the data in the form as it is, that what insights we can get from that. And according to that, those informations, we are going to take the actions which you basically just mentioned.
Okay. I mean, one more question. So, sorry again, not going into depth, but this box plot, right? A lot of outliers we have. One normal suggestion that everyone says, online or some of the other tutorials and everything, replace the outliers with the median value. Is that the popular approach that we do? Because that might change the median value itself again, right? Pushing a lot of outliers to the median again, or the mean. Very briefly, could you touch
No,
upon that?
you are absolutely correct. So again, it is going to highly dependent. It is going to be highly dependent on the type of projects which you are going to do. So I'm going to give one example where you can't do, because that is what your question is. So let's say if you were in a healthcare industry, okay, you will not be able to do or basically replace these data points and put it as, so let's say you are modeling a particular disease, okay, between let's say a couple of diseases, common cold, cancer, and a couple of other diseases, like, right? What's going to happen is common cold is going to be a really common one. Well, you're going to have a lot of people with that and a lot of data points on that. And with cancer, you're going to have a lot less data points. So if you were to replace the cancer one with common cold, that will be a huge mistake, right?
Right.
So it totally depends on the scenarios. In some places, you can totally do that. Okay. In other places, you can totally do that. You can replace, even if the mean will change, even if the median will change, you can still do that. But at different places, at critical places, you will not be able to do that. So you have to identify where you can do that and can't do that. So what you are saying is absolutely correct. We should not do it blindly. We should observe what kind of a data it is, and if we should do it, and what kind of a change we are able to observe by that change.
Thanks, Abhinav. Thank you. That answered my question.
Thank you.
Thank you, Vikram. We have Asma. Asma, I'm unmuting you. You can ask your question.
Hello. I'm actually not a person of the industry. I'm in the teaching line, and I'm not very well versed with all these things. So my question was, can you suggest some blogs or some additional reading material or some study material which we can actually go through so that we understand what is being done a little better?
Yes, absolutely. So a couple of things basically.
Though I have done the foundational courses, so I have a little bit of an idea, but I'm not very well versed.
One thing I will suggest is I have already suggested that go through Kaggle projects. So they have a discussion section. Okay, please. So what happens is people usually discard the discussion section. They do not spend time in the discussion section. Please go for every particular project in the discussion section. You will find a lot of really talented people putting in their insights, their codes, their actual codes, which you will be able to go through that, and you will be able to learn a lot from that. That is one. Apart from that, a lot of learning you can do from subscribing to blogs and newsletters. Okay, so what I'm going to do is I'm going to curate a couple of list of the newsletters. I'm going to ask the moderators to send it across to you, everyone, so that you have it. But I can name a couple of on top of my head. As one is, you should definitely subscribe to Towards Data Science. That is one of the Medium platform. Okay.
So is it for beginners? Like you have to think
yes. It is for beginners. It is for advanced. All sorts of articles are available in there. Then there is called papers with code. Okay.
Yeah,
so
that I have actually referred to at times.
Yeah, papers with code is a really good one that will help you understand along with the paper which you are reading, and it will give you all the open source codes that has been published for each of the projects. That is a good place to not just for the papers, but to find new projects and good projects basically. So that is another one. There is then another platform called Researcher. So it's a application which you can also install on Google, your Android and iOS application. So you can install it, and it basically what it does is it releases papers gradually as it comes in, new papers or papers that is going to be interest of you. So it is going to recommend
like these
that,
are
or you can
published
find
papers
that.
in journals kind of thing.
Yes. So that is a really good platform to discover that.
It is quite different from this Google Scholar, and there's a difference between the two.
Yes. I mean, Google Scholar, you have to go it. So this is a really pocketable. So whenever personally, whenever I have to find something on any particular topic, I can just go into my mobile application and I can just type in that topic and I can find all the papers very, very quickly.
And these are PDFs are available. Like in Google Scholar, many of them we don't have unless we subscribe.
No, in that particular one, you will have PDFs available.
Okay.
That is another one. So as such, there are multiple. So I will curate a list of that. And I will send it out to everyone.
Yeah, because part of it, like I'm in the teaching line. I'm not basically an industry person. So that is the reason. But to keep myself abreast, I have to teach hopefully students. So that's the reason I'm doing this course.
Yeah, no, that is completely true. That is completely true.
That's the reason why I was just thinking.
Even for non-teaching members or students, that is usually beneficial.
Yeah.
Not just for teaching purposes.
Thanks a lot.
Thanks,
Asma. We had someone, Rakesh, if I remember correctly. No, Rajiv. Rajiv, do you want to ask some question? You had your hand raised. Yeah, okay. So I'll just... Rajiv, can you raise your hand again? By that time, we'll go with Siddhant. Yes, Siddhant, do ask your question. I've asked you to unmute. Yeah, Siddhant, go on.
Yeah, hi Abhinav.
Hi Siddhant. Yeah, please tell me.
I am actually pursuing my MSc in biostatistics. So I am having a little hard time from like a theory perspective to a practical perspective, like the industry perspective, basically.
Right.
So my main problem was, like, all of this time I was into orthodox theoretical knowledge. Right now, the thing is, like, the first when you started the presentation, there were a lot of use of the libraries like Pandas, NumPy, and lots of other libraries. So I just wanted to ask, like, how can I be able to understand all of these libraries and like carry on with the project? Because I only know one and two, like Pandas, not also vigorously. So used a lot of libraries and it got me confused. So how can you help me with that?
Yes, absolutely. You have a really great question. So look, the thing is, gradually as you will go on, what you will have to do is you will have to explore a couple of libraries, like for even data handling, you have multiple libraries apart from Pandas. Similarly, TensorFlow, corresponding similar to TensorFlow, you have PyTorch, you have Keras, you have there is another one. So yeah, I mean there are multiple these kind of frameworks as well. So Absolutely, there are going to be at every point in time multiple frameworks and libraries which you are going to encounter, but you will have to explore a little bit or initially and focus initially, measure on one. Okay, just go through a couple of them and see that which strikes with you. Let's say TensorFlow strikes with you. Go ahead and stick with TensorFlow. Okay, because having knowledge in some particular libraries is really, really important. That will increase your efficiency while you are coding. And also another thing is, this is a gradual thing. So please don't worry about getting to know all the syntax, in one go. It will happen gradually as you will do more and more project, as you will start doing coding. So the more coding you will do, the more you will get versed with it, the more easier it will come to you. After a couple of years of massive coding, what will happen is that you will need to know, or you will need to any new libraries. Let's say you encounter any new libraries, you will be able to adapt to the syntax of that libraries very, very quickly. So it's kind of you can think of it like a habitual thing. Okay, so please don't worry about it. Continue coding. Absolutely, if you skip coding and if you're doing only theoretical, you will always struggle with the syntax. And so please don't do that. Always spend a little bit of time on coding on daily basis. So yeah, I mean that's all the advice I can give you.
Thank you, Abhinav. We'll just take the last question for today. We'll take Rajiv's question and then we would have to wrap this up. Also, Abhinav, could you put the links of how to connect with you plus the project link you were talking about in the chat box? Meanwhile, I'll ask Rajiv to raise his hand and I'll ask his question. Yeah,
Yep.
Rajiv, do raise your hand. Yeah. Yeah, go on.
Hello.
Yeah.
Hey,
Hi.
Rajiv. Yeah, please go ahead.
Hello, Abhinav. I'm from manufacturing background and just wanted to understand how these mathematical and statical analysis is going to help in the manufacturing industry in day-to-day solving a problem. Just wanted to correlate.
Yeah. So with the advent of machine learning, a lot of industries, not a lot of, actually, I should say most of the industries are adopting machine learning very, very quickly nowadays. So even the manufacturing industry. So one example that completely comes on top of my mind is managing the supply chain, basically. Okay, and managing the input goods, basically, or the raw goods, basically. So these are the couple of things. So let's say there are a lot of inputs or a lot of raw goods which goes into manufacturing a single product. Okay, so how would you normally increase the basically quality of your built product, and as well as reduce the let's say any kind of a trash or any kind of a wastage of your raw materials? So this is one of the use cases where you can use machine learning to implement that. And similarly, there are thousands of use cases in manufacturing as well. So manufacturing is a domain where you can implement machine learning at quite, quite extensively you can implement.
Thank you, Abhinav. Okay, you can put in your links. There's one more person, PPJ. Will just take his question and we'll wrap this up.
So I was thinking we can send a mail with the links, basically, so that I can put a couple of extra links. That way it will be more helpful for everyone.
Okay. So yeah, thank you, Abhinav, for putting in your time and having this wonderful session. Thank you everyone for joining here with us. For the next episode in this series, we'll be disclosing the details soon. It will be announced via mail
Hey, I think Jigyasa, your voice is not.
Yeah. I'm sorry. I got disconnected for a moment. Am I audible now?
Yes, you are audible.
Yeah. So please do fill up the form, and thank you everyone. Host, we can end up the live stream. Thank you, Abhinav, for your time.
Okay, thank you everyone for planning this out. Thanks everyone who helped in this session. Thanks a lot, and thanks everyone for joining.
We'll keep everyone updated on the further details of this series. Thank you. Host, you can end the meeting. Thank you.